Hi gents, we're gonna go and correct now this piece of work that I let you try out. This was to do with being injective, surjective, bijective. So just a quick reminder, and it's not a bad idea on your exam just to write it down. Injective, every y value has at most one x value. So if you pick a particular y value and you sketch left and right, are you going to hit the graph more than once? If you are, it is not injective. So you can only hit it at most once. So that is 0 or 1 time. So there's no line there that we can draw where it's going to hit twice or more. So this thing is injective. So good there. Every y value has at least one x value. So again, you're going to do a horizontal line. And if you can draw it such that it doesn't hit the graph, then if it doesn't hit the graph, it's not surjective. If it does hit the graph, it is going to be surjective. So every single time we draw a line, it is going to hit our graph. Okay. So every single y value is giving us an x value. So it is surjective. If it's both of those, it is bijective. Good reason, I don't know. I would write down horizontal line test. So horizontal line test, every horizontal line hits the graph once and only once. I suppose you could think of it like that. For this one here, is that injective? Every y value has at most one x. Well, for instance, if you were to draw this y value, that's really appalling. But if you were to look along that horizontal line, it does only hit once. But there are other places, for instance, that horizontal line where it hits once, twice, and in fact it'll be 3 times. That's what makes it a cubic, really. So this one here, it's not injective, okay, because you can draw a line where it'll hit a few times. So this particular x value, let's say that it's x, or so this particular y value, let's say that's y equal to 2, has several, like -2, we'll say 1, we'll say 4, whatever. It has several associated x values. Is it surjective? Is every y value covered? So for instance, is that y value covered? It is, because that will keep on going up. So that's covered there. That will keep on going down. So there's no horizontal line you can draw in where it doesn't hit the graph. So it is surjective. Is it bijective? No. Reason, again, I don't know, hopefully they don't ask you this in the real thing, but what's the sort of thing that they might want you to write down here? Maybe you can say it's not injective because horizontal line test, it hits the graph 3 times. It is bijective because every single horizontal line that you draw is going to hit the graph at least once. Okay, now we get to some tricky things here. Okay, y equals x squared. What does that look like first of all? So you should be able to know what that looks like as a graph. And it looks a little like that. But they are only going to be putting in positive numbers and 0. Positive whole numbers as well. That's worthwhile thinking. And 0. And we're only going to look at positive whole numbers and 0. Okay, those are the things that we're going to look at coming back out. So let's just think about this. So really the only bits, it's not a full line that we're considering. We're only considering 0, 1, 2, 3, 4, and we're only considering 0, 1, 2, 3, 4 when it comes to the y's as well. Okay, those are the x values, these are the y values that we're looking at, and only those. So let's now really think deeply about this. So it says injective, every y value has at most one x value. So that's 1 or none. Okay, so is there any y value, for instance, let's take 4 here. What would 4 be associated with? 4 would be associated with an x value of 2. And you say, okay, yeah, that's fine. That's just one value, but 4 is also associated with -2. So typically here now you would say, oh yeah, well, this thing is not injective on the basis that it has 2 x values. But actually, the only inputs we were looking at were positive whole numbers. So -2 is discounted. We're not looking at that. We're only looking at all these values on this side here. So actually, you can totally forget about what's happening on that side there. So it turns out that for this thing here, it actually is injective. Every y value, every positive y value, only has one positive x value attached to it. Okay, at most. Okay. 3, for instance, as we're about to see, because that's going to be important in a second. 3 does not have an associated value. 3, of course, has √3, but the associated values have to be whole positive numbers, which √3 isn't. So actually that does answer our question for surjective. Surjective means every y value has to be covered. Every positive whole number has to be covered. 3 is not covered. It is covered by √3, but it's not covered by this thing that we're looking for here, which is whole positive numbers. So actually this thing is not surjective. Okay, it is not surjective. Not every y value is covered, and because it's not both things, it's that. Okay. If it was y equals x squared from the reals to the reals, okay, it would not be injective. For instance, if you look at the y value 4, there are 2 x values, 2 and -2, that would give you that. Okay, would it be surjective? It would not be surjective because there's no y value, there's no associated x value that would give you y equals -4, for instance. If you go down to y equals -4, it doesn't hit the graph at all. And to be surjective, it has to hit the graph at least once. Okay, so that is, yeah, that requires real thinking to go with that. I don't know what they ask, such a tricky one in the leaving cert, but put it like this: if you can figure that one out, I definitely suspect anything that they throw at you in the leaving, you'll be fine. Okay, hold on now. They've just changed it up again, so the same one. You can tell that I haven't prepped this because I'm surprised at what's coming along. Okay, so now what they're doing is they're looking from positive reals to positive reals. Okay, so is it injective? In order to be injective, you can only have one or no value attached to it. So what we have to pick is we have to pick a real, positive real number, and we have to say what would that have been back there. So is this injective? Again, I do think it is injective. I think that there's no way to draw the line such that it hits the graph twice, because we're only looking at the positives. So I'm going to say that is injective, yeah. So again, with 4, if you were to take that, you can't include -2. It's only going to be 2. But yeah, here's the real difference then. When it comes to like 3, remember we were saying that there's no positive whole number that's associated with that. Well, there is a positive real number. It's √3. √3 when squared gets sent to 3. And that's going to be the case the whole way. Every single thing is going to hit the graph. So every single y value is going to hit the graph. Now, remember the last time we were saying, well, there's no one for -4. It doesn't hit the graph. But actually what it's saying here is you're only meant to be looking at positive numbers. Okay? You're only meant to be looking at positive numbers. So is it surjective? It is surjective. And since it is both of those things, it is also bijective as well. Okay. And this one here, okay. Y equals x squared from OR to or so that's from the reals. Okay, we're going to be inputting the reals, and we're only going to be getting out positive real numbers. Okay, so again, another little tricky one here to think about. So we can put in anything, but we're only considering positive things to get back out. Okay, injective function. Injective, again, means that when we draw our line, it should only hit once. And we are looking here, well, we can put in anything at this case here, and we're only looking at positives back out. So for instance, if we look at 4, okay, 4, which is a positive real number, there are 2 real numbers associated with it, -2 and 2. Now we can consider -2. Before we couldn't, because it was only taking positive real numbers, and in our previous one it was only taking positive whole numbers. So now we can consider -2. So is it injective? It is not injective, because remember, it's meant to hit only once, and in this case, if you were to look at a y value of 4 across left and right, it's going to hit where x is 2 and where x is -2. So that's 2 places, that's more than 1. Now, is it surjective? Okay, so is every y value used up? So if we're only looking at the positive ones here, it looks like every y value gets used up, yeah. Okay, every single. If you just draw lines for all the y being positive numbers, it'll always hit your graph. In fact, it'll always hit it twice, apart from at 0 where it hits just once, but it says that it has to hit at least once, and they all do hit at least once. So in this case, it is surjective, and it's not bijective. Wow. Now that is a tough question for sure. This one here, it's just a trick. Okay, is it injective, surjective, bijective? It's none of those, because it's not a function. Why is it not a function? It should be the case that whenever you have a function, it's fine to do a horizontal line and hit twice, but you cannot draw a vertical line and hit twice. What would this mean? This would mean that an x value, let's say 2, goes to 2 different places, and you can't have it. That is not a function. So a function, if we were to draw our axis, it can do whatever it wants, like that. What it may not do is it can't double back on itself. The second you double back on itself, it would fail. We'd call it the vertical line test. If it hits it twice, you are not dealing with a function. So therefore, it's none of those things, not a function. Okay, hope that was helpful. Trust me, that one is really tricky, and if you do go on to do something mathsy in college, that's going to be helpful for sure. Take care.